Welcome to the introductory video for Solinteg Smart Meter and CT. We've organized this video into 5 parts: introduction, appearance, application, configuration, and Q&A section. Let's start with the first one, the introduction. The smart meter device includes the meter and the CT, the abbreviation of current transformer. The main function of the smart meter is to work in conjunction with an inverter, enabling the entire system to implement 24-hour load consumption monitoring and accurate export limitation functionality. Solinteg Smart Meter has 2 versions, RMM meter and RMK meter. Normally, RMM meters are used with hybrid inverters, while RMK meters are used with on-grid inverters to achieve 24-hour load monitoring and export limit functions. The smart meter boasts 0.5 S-level precision, ensuring a deviation not exceeding plus or minus 0.5% and high current measurement accuracy. Its versatility extends beyond residential use, making it applicable for commercial and industrial projects. This smart meter demonstrates high compatibility with various grid types, accommodating voltages ranging from 230 to 400 volts and supporting 3-phase, split-phase, and single-phase configurations. The user-friendly features include an OLED display and 4 physical buttons, facilitating real-time data checks and easy configuration settings. In terms of communication methods, RMM meters communicate solely with inverters via RS-485. RMK meters offer greater flexibility by communicating not only with inverters but also with routers through Wi-Fi and LAN. Installation and removal are simplified, thanks to a convenient retaining clip that securely clamps the meter onto the DIN 35mm rail. The main function of the smart meter, as we have mentioned, is to work in conjunction with the inverter as an intelligent EMS device, enabling the entire system to implement 24-hour load consumption monitoring and accurate export limitation functionality. The primary difference lies in their communication methods, influencing their compatibility with different types of inverters. RMK meters come equipped with an internal communication module, allowing them to communicate with routers via Wi-Fi or LAN. Additionally, RMK meters are powered directly by the grid, enabling them to operate 24 hours a day, even during nighttime. This makes them suitable for on-grid inverters like the OGS series and OGT series. Even if the on-grid inverter stops working at night, it also remains functional, ensuring uninterrupted data transmission to the server. A crucial point to note is that if you choose RMK for data communication with the server, please avoid installing and configuring communication modules for the inverter. Redundant communication with the server could result in data discrepancies on the monitoring platform. About the RMM meter, it doesn't have an internal communication module like RMK meter, so RMM meter can only communicate with inverter and upload data through inverter to server. The hybrid inverter can operate 24 hours a day, providing a stable medium for communication, so RMM meter is commonly used in conjunction with hybrid systems. If the RMM meter is paired with the on-grid inverter, the data detected by the meter at night cannot be uploaded to the server because the on-grid inverter is not operational during the night. This means that 24-hour load consumption monitoring cannot be achieved, and monitoring can only take place during the daylight hours when the on-grid inverter is operational. In addition to being classified as RMK and RMM series based on the communication method, the smart meters are also categorized into milliampere and 5 ampere series based on the rated current of secondary side. Pairing them up results in 4 different versions in total: RMK milliampere, RMK 5 ampere, RMM milliampere, and RMM 5 ampere. The milliampere meter's secondary side rated current less than 100 milliampere, while the 5 ampere meter's secondary side rated current less than 5 ampere. Typically, the current on the phase line detected by the CT represents primary side current. The current collected through the CT transformation ratio and sent to the meter is considered secondary side current. The classification criterion between the milliampere series and the 5 ampere series lies in the difference in the detectable current magnitude on the secondary side, marking one of the main distinctions between the 2 series. Here we can see the key parameters of the 4 versions. From this table, we can observe common features shared by these 4 versions of smart meters: robust adaptability to various power grids, high precision, and convenient methods of use and installation. Additionally, we can extract the differences among these 4 versions. About RMM meter and RMK meter, the main difference is the communication method, as we discussed. RMM meters communicate solely with inverters via RS-485. RMK meters offer greater flexibility by communicating not only with inverters but also with routers through Wi-Fi and LAN. There are also slight differences in self-consumption. RMM meter is generally paired with hybrid inverter as MHS and MHT series, and also can be used with OGT series. It should be noted that the 24-hour load consumption monitoring function will not be achieved in the case of the OGT series paired with RMM meter. RMK meter is usually paired with on-grid inverter like OGS and OGT series. The main differences between the milliampere and 5 ampere versions lie in 2 aspects: the selection and configuration of the CT and the magnitude of the secondary side current. For the milliampere version, the smart meter is matched with CT before shipping. Simply choose the appropriate CT based on the primary side current magnitude and wire diameter in each single phase. All configurations will be preset before shipping, and upon arrival, no additional setup is required for installation. We provide 3 options for the primary side current magnitude of the CT to choose: 120 amperes, 200 amperes and 300 amperes, suitable to a wide range of applications, including residential as well as small commercial and industrial settings. In contrast, the 5 ampere version does not include the CT, requiring customers to purchase and configure it independently. This approach offers several advantages. Firstly, it increases the upper limit of the current detection capability on the primary side, supporting a maximum of 5,000 amperes for primary side current detection. This makes it especially well suited for larger commercial and industrial applications. Secondly, it provides greater flexibility and choice for customers, allowing them to select CTs that best suit their specific situations and needs. However, it's crucial to note that any independently purchased CT must be a 5 ampere CT to avoid data confusion. Next part, let's move on to appearance of the smart meter. The front panel includes a OLED display and 4 physical buttons with different functions, providing good usability for operation. The top 4 ports are designated for power grid connections, with L1, L2, L3 connecting to live lines, and N connecting to the neutral line from left to right, respectively. The retaining clip and rail groove are used for installation and removal. By sliding the clip, you can secure the rail groove onto the rail, completing the installation. Similarly, when disassembling, simply slide the clip to effortlessly remove the smart meter from rail. The right side of the page shows the ports at the bottom. The outermost edges ports are used to respectively connect the CT, the protecting earthing wire, and the RS-485 signal line. When it comes to wiring, it's crucial to note that the phase port at the top of the meter should correspond 1-to-1 with the CT port at the bottom. Additionally, consideration should be given to whether it is a single-phase or 3-phase application, as the type and wiring methods of the smart meter will vary accordingly. When used in a single-phase situation, connect N port wire to the neutral line, the wire from L1 port connects to the live line, and the CT form CT1 port should be installed on the live line. Next, it's important to align the direction of the CT with the direction of the load to the power grid. The direction of the CT is located inside. The arrow from P1 to P2 means load to grid. If it is used for a 3-phase situation, firstly, confirm the direction of the load to the power grid and ensure the installation orientation of the CT. Afterward, proceed with the wiring installation. The wire form L1 port should connect to the L1 line, the CT connected to the CT1 port should be installed on the L1 phase. Similarly, the wire from L2 port connects to the L2 line, the CT from CT2 port should be installed on the L2 phase. And the L3 port connects to L3 line, the remaining CT with CT3 port connects to the L3 line. And then N port wire connect the neutral line. The connection order must not be mistaken, otherwise, the detection data will be inaccurate. Beyond these considerations, the meter incorporates two RS-485 ports at the bottom and a debug port for maintenance. Notably, the RMK version offers additional connectivity options, featuring a LAN port and an antenna port. These additions enhance communication capabilities, allowing seamless interaction with routers for advanced functionalities. The milliampere version of the smart meter comes pre-configured, with each CT in the package calibrated and tested. It's imperative to note that these CTs are specific to the meter and cannot be interchanged with other CTs within the same device or across different devices. During installation, strict adherence to the internal current direction mark is crucial. The arrow on the CT indicates the direction from the load to the power grid, and any incorrect or reversed installation can result in data errors. When it comes to selecting a CT, it's essential to choose one based on the magnitude of the primary side current and the wire diameter. This ensures accurate and reliable data detection. The screen in the front panel can show the communication method and status with inverter and server. When the connection ports or methods differ, the meter screen will display different icons for easy user reference. Moving forward, let's delve into the application scenarios for the smart meter and CT. First one, RMK meter is used with OGS series inverter. The smart meter connects with inverter by RS-485, as illustrated in the wiring diagram below. CT is installed between the load and grid meter with correct direction to detect the export or import current. And then the data can be uploaded to the server via Wi-Fi or LAN. When the export limit function is enabled, once the CT detects current feeding into the grid, the data will be transmitted through the meter to the inverter. The inverter will then decrease power to match the load consumption, preventing any excess current from flowing back into the grid. This process enables the export limitation function. About the 24-hour load consumption monitoring function. The power value at point 1 represents the inverter's output power. The CT connected to the smart meter detects the current in each single phase, providing the power value at point 2. The power value at point 3 denotes the load consumption. During the daytime, the power values at points 1 and 2 can be detected respectively, with the power value at point 3 calculated as the power value at points 1 subtracts point 2. For the on-grid inverter, at night, with no power at point 1, the power value at point 2 can be read by the meter, and the load consumption at point 3 equals the power value at point 2. This is the fundamental principle of the 24-hour load consumption function. In this way, the 24-hour monitoring function and export limitation function can be realized. The single-phase on-grid inverter, OGS extended version inverter, can connect the CT directly by COM2 port as the wiring diagram shows. This method can achieve export limitation function. It should be stressed that only OGS extended version has this configuration. This page shows the RMK meter in conjunction with the OGT series. It is similar with OGS series. The difference lies only in the application for 3-phase with 3 CTs, so the installer needs to strictly follow the previously mentioned installation order during the installation process. The basic principles of functionality implementation are the same. The OGT series also can use RMM meter, but it cannot achieve the 24-hour load monitoring because the data at night can't be uploaded to server. The usual practice is to combine RMM meter with the hybrid inverter, like single-phase MHS series and 3-phase MHT series. Let's see the diagram of MHS series and RMM meter. With the presence of energy storage batteries, the hybrid inverter can operate 24 hours a day. As a result, data collected by the RMM meter can be transmitted to the inverter by RS-485 and upload the data to server through the communication module of the hybrid inverter, enabling 24-hour load consumption monitoring and management. Following the previously explained principles, the export limitation function can also be realized. The application scenarios for 3-phase systems are fundamentally similar to those for single-phase systems. Solinteg Smart Meters can also be applied in AC-coupled systems, assisting the entire system in achieving load consumption monitoring function. In the system, hybrid inverter is paired with RMM meter, while on-grid inverter is paired with RMK meter. Even if the on-grid inverter is from a different brand, the RMM meter can still be used to achieve 24-hour load consumption monitoring. However, since we cannot control the output power of inverters from other brands, the export limitation function cannot be realized. Therefore, if both the on-grid and hybrid inverters are from Solinteg, the entire AC-coupled system can simultaneously achieve export limitation and 24-hour load consumption monitoring functions. Similarly, the same functionality can be achieved in three-phase applications. About the hybrid master-slave parallel system, the entire system only requires one RMM meter connected to the master inverter via RS-485, while communication between master and slave or slave and slave, and then configure communication for the master inverter, enabling the entire system to implement export limitation and 24-hour load monitoring functions. This page shows the multiple inverters system. With the assistance of data logger, on-grid inverters with RS-485 communication support parallel connection up to 90 units, and hybrid inverters with CAN communication support up to 10 units for paralleling connection. It should be noted that the inverters must be of the same type. All the inverters connected to a data logger must all be hybrid or all be on-grid. Whether it's a multiple inverter system for on-grid or hybrid, connecting just one RMM meter to a data logger is sufficient to enable the entire system's export limitation and 24-hour load monitoring functions. Next part is the configuration. In this section, we will cover the configuration process for various settings. During the installation, RMK meter need to do the network configuration to connect with router. And 5 ampere version meter need to set the CT ratio. And the configuration of grid type or grid frequency should be determined based on the actual requirements of the site. The detailed steps will be illustrated on the following page. Here shows the RMK series network configuration steps. First, press enter button to input password, and the default password is 1000. Next, choose the common set. Press enter and then press up or down button to switch to connect type. Enter and choose the correct network type. Finally, press enter to save the setting. This concludes the configuration process for the network. Similarly, following the provided steps will allow you to complete other configurations effortlessly. Here is the grid type configuration steps. The default grid type is Y. If the on-site grid conditions match the default settings, there is no need for further configuration. This page shows grid frequency configuration procedures. The default grid frequency is 50 Hz. This page shows the CT ratio configuration. CT ratio of milliampere series is fixed and cannot change, but CT ratio of 5 ampere series need to be set. The maximum upper limit for the CT ratio is 1000 to 1, meaning it supports detecting a maximum of 5000 ampere on the primary side current. When purchasing the CT for 5 ampere version meter, it is necessary to estimate the current magnitude based on the usage requirements of your own load. Assess the ratio of the CT that needs to be purchased, and then input the CT ratio into the meter settings. For example, if the estimated current magnitude on a single phase is 500 ampere, you will need to purchase a CT with a ratio of 100 to 1. After installation, you need to set the CT ratio to 100 to 1 in the meter settings. The last part is the question and answer part. Here we collect some common questions, and we will also gradually improve the question library. You can check it when you encounter the problems, and if you have any question, you can contact us to help us improve the question library. This is the entire content of Solinteg Smart Meter and CT. If you have any question and suggestion, please feel free to contact us. See you in the next video.